Today we will talk about chemistry and matter. So when we are thinking about chemistry, we have to say, okay, we know that in the world we have some liquids, for example, water and vinegar. We also know that we have solids, for example, amethyst here and granite. We also have gases, and for example, you can inhale oxygen and nitrogen and exhale more carbon dioxide that you inhale. So a lot of things going on right here. But when you think of matter, they are grouped in two distinct ways. First one, they're called mixtures, and the second, they're called pure substances. Now, keeping in mind that in elementary school, often we tend to talk about mixtures because they are the easiest one, and mixtures are divided in two groups. So the two groups that we divide mixtures are homogeneous mixtures and heterogeneous mixtures. So let me give you some examples. So if you think of vinegar, vinegar is a liquid. In here you've got the vinegar diluted in water. So that means here we have a mixture of different compounds. And on top of that, these compounds, we call them homogeneous because we cannot identify specific pieces. They are all mixed nicely together. Another example of homogeneous. So here I have, for example, a piece of aluminum. This is made of 100% aluminum. Oops, that's a bad example. Here we're talking about mixtures. That's not the one I wanted to give you, is this one. An example of an homogeneous composition is this lava rock. This lava rock here is solidified. So when magma comes up, so this one here is from Hawaii. When magma comes up, what happens here is it quenches very quickly, dries very quickly. So it doesn't have time to create individual minerals to be able to have very specific textures. So here we have a homogeneous lava that's solidified. So this is what we called homogeneous. We cannot identify the individual pieces. They are all put together. We can have that in air. For example, the air we breathe is a mix of nitrogen, oxygen, carbon dioxide, and a few other gases. It is homogeneous. Good. Now it brings us to this idea of heterogeneous mixtures. So the best one I have for you is this one here. So if you look, I have here a test tube, and here I have oil at the top. Or is it oil or ethanol? That's a good question. I forget. I'll have to double check. But this is a substance that is lighter than water. And here we have little particles that are lighter than water, but heavier than, I think it's ethanol, not that I remember. And at the bottom, you have white pieces of plastic. So here it is all nicely divided. If I shake it and I look at it like this, it's all nicely put together, but here you have some white particles getting together. But at the top here, you will quickly see that, I think it's ethanol. Ethanol, it decided to go at the top here, and because it's lighter. And we have here the water here that is becoming, that is dividing. So here is an example of different matter that are divided. But if you are mixing it like this, it's all mixed together. This is heterogeneous. For example, if you have a cookie dough or you have cookies with the chocolate chip, that's an example of heterogeneous materials. Now, sometimes when we have something like this or salt water, you can extract some of the compounds from the water with distillation, or by evaporating the water, you're left with the salt at the end. Another way you can do this is with, where are they? I had some magnets this morning. So where did I put them? Give me a second. So I have this right here. It must be somewhere. I used them about 10 minutes ago. Let's have this one. Oh, there they are. If you think, for example, magnets do attract iron, for example, but will not attract plastic, will not attract foam, for example. And the reason for that is that this is a particularity of iron, we can use magnets. Now, if you think of recyclable materials that you put in your recycling bin, what happens often is that when it goes to the recycler, they will take a magnet to take metal out. They might use water for different density. So what happens here is that we're using different properties to divide the mixtures. So that's what mixtures are all about. This year in grade 9, we're going to focus on what we call pure substances. Pure substances are made of only one piece of information, one type of materials. So give me a moment. I'm going to share with you in a moment how we divide those two. The second part of this video is about pure substances. So let's see how it is divided. It is divided in two distinct parts. The first one is called elements, and the second one is called compounds. Now, some of you may have heard of elements before, and let's see if I can show you a periodic table. Because when we have a periodic table, it is one way for us. Let's see, share screen, Windows. Perfect. When you have a periodic table like this one, it is a way to organize the naturally occurring individual type of substance. So here you can have, for example, iron. So here, when I click on one of the square, it gives us here some information. So we have magnesium, we have iron. So often, if you think of the paperclip made of iron, maybe steel, that's a good question. We see it's iron here. We have carbon that is right here. We have oxygen that is right here. What's interesting here is that we have a periodic table of elements. That means that they are made of one type of substance, made of one type of particles. So let's see if I can show you an example. So here, if you think here, I have here a cylinder of aluminum. This tube of aluminum is made of one type of matter. It's made of aluminum. So if I take this tube, you can see it's all full, and I cut it in half, and I cut it in half, and I cut it in half. It will get to a point where I will end up with one particle of aluminum. The only type of particles in this is aluminum. And here we can identify where we can identify it on the periodic table. And aluminum is right here. As you can see in the upper left corner, aluminum has some specific information about it. The second one I'm going to show you is copper right here. Copper has its individual space on the periodic table with specific information and characteristic. So if I show you what it is. So here I went to a metal supermarket. This is made of copper. So this is a bit oxidized, but you could see how pink it is. Let's see, do I still have and paper here? I had some paper, and I think that I don't have any here. That's okay. So we have here a piece of copper. If you were to take this piece of copper and divide in half, at some point you would end up with only one particle of copper made of one type of matter. This is what we call an element. So here on the list, I have, for example, aluminum. I give you an example, iron. For example, you have an iron nails. I talked about copper, gold as well. If you have pure gold, it's made of one type of materials. So if you look here on the periodic table, we talked about aluminum right here. We talked about copper right here. Gold is down this way. So when we have pure substances made of only one type of particles, we call them elements. Now, what's interesting here is that when you have one particle of one type of pure substance, one particle is an atom. When you put several atoms of the same matter, we call it an element. And then we group them on the periodic table with some examples. Now that brings us to what compounds are. Compounds are pure substances as well. What's interesting here is that if you were to take, let's see if I can have a good example here. Let's see, I had a good example earlier. I don't know where I put it. So let's see, we can have water. Okay. So give me a second. I have a, let's see, compound. Okay. Okay, let's use this. So here I have a pipe, and the pipe is made of plastic. There's a specific type of plastic with a specific color. If you were to take this piece of plastic and break it down in small pieces, small pieces, small pieces, you will end up with one small particle of plastic made of one type of particles. And here I have to assume that the overall composition of this plastic is the same throughout. If you had a glass of water is made of, and if it is distilled water, so made of only water, and if you have a, let's say 100 milliliter, you cut it in half to 50 mil, cut it in half to 25, cut it in half, cut it in half. Eventually you end up with one particle of water called a molecule. And when you put many molecules of water together, you have a compound, which is your glass of water. So that works the same. That works with carbon dioxide as well. If you have carbon dioxide as a container and you break it down in small pieces, you end up with one particle of carbon dioxide. Now, what's interesting with molecules and compounds, we can go back to our periodic table, is that if you have carbon dioxide is made of carbon and oxygen. So here what's interesting here is that we have two atoms that are put together to create a new substance. And in that case, it is a molecule or a compound. If you think my example is water, so we have oxygen here and hydrogen. So you put different types of atoms together to create a molecule. You put many molecules that are exactly the same, you end up with a compound. We talked about plastic. Plastics are made of carbon and hydrogen, and sometimes there's some oxygen in specific orders and specific grouping. This specific grouping is called a molecule. You put many of them together, and you end up with a compound. So this is the big difference between what we talked about today, a mixture and pure substances. And pure substances are divided in elements and compounds, and this is what we'll be talking about this semester in grade 9. If you have any clarification questions about this intro here of chemistry, put your questions in the comments below. Otherwise, I will be leading you to another video about chemistry that I'm going to put here to learn something new again. I'll see you there.